This video is on the objective graph a lemniscate from a polar equation. So a lemniscate, basically like a figure eight in most cases. This is another one of those special types of classic curves that they're calling them, of a polar graph. And you had your cardioids, you got your limaçons, which a cardioid is just a special kind of limaçon. These lemniscates and also rose curves, all these are addressed in some kind of objective in this section, in this assignment. So here we're talking about lemniscates. So if you want to get more into the topic, click on more instruction at the bottom here, and look at the notes, the videos, the examples they have, and hopefully those help you. Now I'm going to show you some of that, some of the notes they have in the more instruction on investigating lemniscates. So the lemniscate is a polar curve resembling the infinity symbol, or a figure eight, centered at the pole. Right? A lemniscate is symmetrical by definition. So some formulas, the general formula for a lemniscate. The formulas that generate the graph of a lemniscate are given by r squared equals really just some number. I know they've got a positive number here. A squared would be a positive number, but we'll see in the problem we have it's a negative number. But some number times the cosine of 2 theta, or r squared equals some number times the sine of 2 theta. And so the argument, the thing inside the sine or cosine has to be 2 theta here, and we're talking r squared equals, not r equals. All right. But I will look at the square root, right, just to get r in a little bit. Okay, so here's some examples of some lemniscates. And I see some of them have a minus sign in front, which is totally fine, but all these end up being some sort of figure eight or infinity symbol shape centered at the pole. And they show an example down here and stuff, but let's just get now into our example, right, the problem I'm looking at. So it's, r squared equals negative 25 times the cosine of 2 theta. So let's take a look at this. So this is going to take a little more investigation than your cardioids and limaçons and rose curves, because of the fact that there's r squared here instead of r. So we have r squared equals negative 25 times the cosine of 2 theta. All right. Now you got to remember, when a real number is squared, the result will be non-negative. So what I'm going to do first is I'm going to look for the values of theta for which this expression on the right side is non-negative, because those will be the only allowed values of theta. Anything that makes this side negative won't be part of this. I can't do it. You can't square a real number and get a negative output. So I'm going to look for the values of theta for which negative 25 times the cosine of 2 theta is non-negative, is greater than or equal to 0. Right. And again, the only reason I'm doing this is because this is r squared here, and then these will be the only allowed values of theta. All right, so I'm going to take a look at, let's take a look at the graph of just this expression, and then we'll look at the square root of it and stuff. Right. So look at y equals negative 25 times the cosine of 2x, right? If I replaced theta with x. Now I'm not replacing r with y. I'm replacing r squared with y here. So little different than other graphs you may have seen me do. So this is the typical way we're used to graphing. Now again, y kind of represents r, the value of r squared, and x represents the value of theta. If I was graphing this, the period of this would be pi. So from 0 to pi here, and I'll draw two of them, because when we go to graph on the polar grid, I want to go all the way around the polar grid, so I'd like to have this to 2 pi. And when we get the period's pi though, right? So whatever I graph from 0 to pi is just going to be repeated from pi to 2 pi. All right, so I break this period into quarters. This would be pi over 4, pi over 2, 3 pi over 4, and pi. That's not a good quarter. And I'll break this into quarters as well. This period, this would be a 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay. All right. Then when I plug stuff in, the cosine, remember, goes from -1 to +1. So this is going from -25 to +25. And the cosine of 0 was 1, so my first output's -25. And then when I plug in pi over 4, I'll get 0. And when I plug in pi over 2, I'll get 25. And when I plug in 3 pi over 4, I'll get 0. And when I plug in pi, I'll get -25. And then this picture for r squared would repeat again. Right? So back here, 0 there, 25 there, 0 there, and -25 here. Now remember, these parts of the graphs where the output is negative, right, can't happen. Because again, you can't square a real number and get negative outputs. So this graph is the only allowed values of theta are between, where the outputs are positive here, are for this graph, part of the graph where outputs are positive, and this part of the graph where outputs are positive. Right. And yeah. So the only allowed values are between pi over 4 and 3 pi over 4, and between 5 pi over 4 and 7 pi over 4. All right, and now let me take the square roots of these positive outputs, right? Because this is r squared equals -25 times the cosine. So let's look at r equals, plus or minus the square root of this. All right, and I'll do this on the next page. So now let's look at the graph of y equals, plus or minus the square root of -25 times the cosine of 2x. All right, so again, all I'm going to be doing here, now this plus or minus, so there's going to be like a top half and a bottom half to this. All I'm doing is, again, x represents theta, and now y represents r. Right? Now y represents r instead of r squared, because I did the square root. So I'm only looking, between pi over 4 and 3 pi over 4. Right? And then I'm only looking between 5 pi over 4 and 7 pi over 4, because those are the only allowable values here. And then everywhere else, there's not going to be any graph. All right, now basically, remember, when you take the square root of a positive number, there are two possibilities. All right, if I said r squared was equal to one of these, there are two possibilities. Now we're going to, instead of going up to 25, the square root of that is 5. And the square root of 25 could be 5 or negative 5, and this is the plus or minus. And then basically this hump gets shorter. All right, the square root of 0, 0, and then this hump just gets shorter and kind of repeats down here. Oops. The top half is the positive square root, and then this bottom half is the negative square root. Right? So I'm graphing both on the same picture. Same thing over here. Top half, bottom half. Right, where again the value of r is going up to 5 and down to negative 5 and all that. All right. So really I just need to well, let me show you. I'll just graph what corresponds to this top half, and that should be good enough to help me fill in the rest of that lemniscate. All right. So now I'm going to go to a grid. We're going to make a polar grid. So remember how the polar grid looks. You got vertical axis, which really doesn't mean anything. Just breaks things into quadrants and stuff. And the horizontal axis, our polar axis. And again, for this graph here, right, the largest values of r is going to be 5. So here's r equals 1, 2, 3, 4, 5. And I'll draw, this circle with a radius of 5 on here. So there we go. A circle with a radius of 5, doing the best I can. I mean, this isn't going to be great, perfectly circular, but so there's a circle with a radius of 5. And then I'll start putting in these special angles that showed up here. Some lines that correspond to those. So back on this original graph, theta equals 0 is this corresponds to the positive polar axis. Then we had basically every pi over 4. All right, every pi over 4. So here's this line. Theta equals pi over 4, and then the vertical axis for pi over 2, and this line for 3 pi over 4, but 3 pi over 4 over here. Right? This the horizontal axis for pi, and then 5 pi over 4, 3 pi over 2, 7 pi over 4, and then back to 2 pi. Right? Okay. Now, look at this graph of the square root thing. Right? So you see from 0 to pi over 4, so between this, this line here and this line there, there's no graph. There's no graph. Now between pi over 4 and pi over 2, I'm looking at this part of the picture, I'm going from r equals 0 up to r equals 5. So starting here at the pi over 4 line, r equals 0 means I'm at the origin. And I have to end at r equals 5. So I'm kind of doing this curvy thing out here, ending at r equals 5. Right. So it's kind of like half a petal from those rose curves. When you get to those, you'll see some petals. And then you see from pi over 2 to 3 pi over 4. So between here and here, got positive values of r, right? I'm going from r equals 5 to r equals 0, so I have to end back at the origin when I hit this line. So then coming back down, ending back at the origin. So there's like 1/2 of the figure 8. Now you could get the other half of the figure 8 if you do the bottom half of this. Right? If you do the bottom half of the graph, the negative square root, you'd get the other half of the figure 8 down here. Because between pi over 4 and pi over 2, that's between here and here, if you have negative values of r, you're not going to be in quadrant 1, you're going to be graphing down here in quadrant 3 on the opposite side, right? When values of r are opposites, you're on the opposite side of the circle, you're in the opposing quadrant. So if I graphed this part of the graph, it'd be going from r equals 0 to r equals negative 5, so down here, I'd be down here and have to end up here. And then this part of the graph would correspond to going back. And there's your figure 8. Now, if you didn't graph the negative square root, that would have been all right. You could have also gotten this piece of graph down here, looking at this part of the graph, up here, from 5 pi over 4 to 3 pi over 2. So between here and here, Again, I got positive values of r, so I'm staying there. If I had negative values of r, I'd graph over here, but I got positive values of r. All right. So, and then I'm going from r equals 0 to 5. So 0 to 5, that's this piece of the graph here. Corresponds to that piece of the graph up there. And then this piece of the graph up here would correspond to going back. So there's your lemniscate. Right, this figure 8 shape going up and down like this. All right, and just pay attention, right? These points on the outer edge have to be 5 units away from the origin, right? Have to be on a circle with a radius of 5. Now let me actually graph this for you on a website. All right, let me go to that desmos.com, right? Free online graphing calculator, and show you a much prettier picture. Now I don't know if they actually allow you to do r squared equals. But let's see, r squared equals negative 25 times the cosine of 2 theta. And no, they don't do that. So I'm going to put in the positive square root. Yeah, see, polar equations must be linear in r, so I have r to the first power. So get rid of that. Now let me just clear the whole thing. R equals, and then the square root of negative 25 times the cosine of 2 theta. And there you go. All right. So that was that positive square root. And even if you graph the negative square root, due to the symmetry, you'd get the same graph. But you see this lemniscate, this figure 8 shape that I drew. This is a much prettier picture. And you see how the top point here, when I zoom in a bit, you see how the top point's 5 units away from the origin, bottom point's 5 units away from the origin, as I hoped for. Okay. All right, and then back on the problem, that's not it, that's not it. This might be it, but you got to pay attention. Are that top point and bottom point 5 units away from the origin? Yeah, they look like they're on a circle with a radius between 4 and 6. So this looks like it here. And that's just opening the wrong way. So this is our lemniscate. Okay, wonderful. Okay, so again, a lot to think about there, right? Especially because there's r squared, right? With this lemniscate business, r squared equals some number times the sine of 2 theta, or r squared equals some number times the cosine of 2 theta. But again, a lot to think about, what values of theta are allowed, right? Because you can't have a real number squared be negative, so you got to make sure that right side is always going to be some non-negative number, 0 or greater. Or you could just, take the square root, look at the positive square root, and go to Desmos, punch it into Desmos, or some other graphing calculator that you might have, and take a look at what graph is popping up and use that. Right? I have no problem with that either. Just wanted to show you where it came from by hand, though, at least once. All right, so hopefully watching me go over this, looking at Desmos, using that to help you out, looking at the more instruction when you need to, reading the answer explanations when they come up. I'm hoping all this stuff helps you when you go about doing this on your own. All right, thank you very much for watching.